Apart from a handful of reserved words, nearly all the words you see in a script are names for values and objects and functions that your script uses or works on. These names are either predefined by MaxScript or created by your scripts. The predefined ones name useful values and objects and sets and functions that are built into MaxScript, such as the creatable classes or the scene object subsets, various system settings, scene file info, the thousands of built-in functions and commands, as well as many others. We've seen a couple of ways scripts can define new names, namely loop variables and rollout definitions, and I want to explore more now. These names are also known as variables because their definitions can vary from time to time and because they're similar to variables in algebra. One of the simplest ways to define or redefine a variable is with the assignment construct, like this. This says, assign the value 23 to the variable x, and it will either make a new variable if x has not already been defined, or replace its current value if it has. It can be useful to think of a variable as a named slot in memory or a cell in a spreadsheet, and think of assignment as putting a new value into that slot or cell. Anytime you introduce a new variable, MaxScript automatically allocates a new slot in memory to hold the assigned value. Variables in MaxScript are also one-size-fits-all and can hold any type of value. Assignments are just another kind of action, and so are sequenced in the ways we've seen so far, including inside if and for statements. Once you've made an assignment, any reference to that variable will use the assigned value until you assign another value to it. So let's follow this along. This assigns a new text string to the variable x. When I use x in the next statement, MaxScript digs out that value and uses it, so the print function will print out the string. Remember that I can evaluate any expression directly in the listener, so I can also simply evaluate x and it'll display its current value. Next, the if statement will determine which sphere has the larger radius and assign it to x. You can see it compares the radius of sphere 1 to the radius of sphere 2 and does one of the two assignments based on that test. Next, I use the copy function again, but instead of specifying an object by scene object name, I'm using the variable x, which now contains the larger of the two spheres because of the previous if statement. The copy function yields the clone object as its value, which I assign to the new variable y. And finally, another property assignment, this time increasing the radius of the clone held in the variable y by the distance between box 1 and box 2. This says get the current value of y's radius and add it to the distance between box 1 to box 2, and then assign that as the updated value of y's radius. Note here that I'm using the same thing on both sides of the equal sign. This highlights a difference between assignments in many programming languages and equations in algebra, which they look like and can be confused with. For example, I can write x equals x plus 2 in MaxScript and it's perfectly okay, but it's nonsense as an algebraic equation. An equation defines a relationship that holds over a set of values, whereas an assignment specifies an action, in this case taking the current value in x, adding 2 to that value, and putting the result back in x. If you try to use a variable before assigning a value to it, your script will almost certainly fail with an error. Undefined variables yield the special value undefined when you use them, as in this case if I try to evaluate a new variable in the listener. This special value will generate an error when used as a function or function parameter or in a math expression. If you see these kinds of errors, you've missed initializing a variable somewhere. To make it easier for MaxScript to understand scripts, there are a bunch of rules governing exactly how you can write numbers and text strings and scene object names and the other basic elements in a script, including variable names. Names can consist only of upper or lowercase alphabetic characters, or the underscore character, or the digits, but they cannot begin with a digit. They can be any length and are not case sensitive. So these are valid names, but these are not valid. Here the first character is not an alphabetic character. Here question mark is not one of the allowed characters. Spaces are not allowed in names either, nor are open and closed parentheses. In contrast to most general-purpose programming languages, MaxScript names are not case-sensitive. For example, all these names refer to the same variable. As scripts get large, and as you start to use many different scripts in the scene, perhaps even written by different people, you can imagine that there is a high probability that different bits of code will end up trying to create and use the same variable names, possibly messing one another up. This could be a big potential problem, but fortunately MaxScript provides a way to organize variables used in different parts of a script into separate hierarchical groups that do not clash. These groups are known as namespaces or environments, and some are built in and some you create in your scripts. Some are long-lived and some short-lived. This sounds complicated perhaps, but it mostly falls out automatically as you organize the structure of larger scripts. Let's revisit a script we've already seen to begin exploring how all this turns up. This is the sphere creator rollout definition. The code has a nested structure, which I hinted at when I talked about using indentation to show the relationships of parts of the code. At the outer level is the rollout definition header and surrounding parentheses. At the next level are the control specs and the header line for the pressed event handler. Inside the handler is the for loop, and inside the for loop is the sphere constructor. This structure naturally reflects the association and control relationships in the script. MaxScript automatically creates nested namespaces to mirror the code structure that you write. At the outermost level is the global namespace shared by all code, and variables defined at this level are known as global variables. Nearly all the predefined built-in variables are global variables. As the code stands here, the sphere toolname becomes a new global variable containing the rollout definition. There is a different namespace associated with the level inside the parentheses, known as a local namespace, or local environment, sometimes local scope. The names count and growth and create become local variables in this namespace, containing the control specs and handlers. This namespace is nested inside the global namespace, so that code at that level can access both local variables and all the global variables. Importantly, code outside the definition cannot directly use the variables inside it. They're effectively walled off and not visible to the outside code. For example, if I try to reference count out here, I get undefined. This also means I can define a count variable out here for some other purpose, and it won't clash with the variable inside the definition. Since code inside this level can see both its local namespace and the global namespace, there's a chance I will define a local variable with the same name as an existing global. You're allowed to do this, and the local variable effectively hides the global variable for the code inside that nesting. There will be two variables with the same name, one at the local level and one at the global level, but the nested code only ever touches the local one. The next level in is the body of the button press handler, but it doesn't have any new variables in it. The level inside this is the body of the for loop, and its namespace has one variable, the loop variable I. Since this namespace is nested down inside the handler, any code outside the handler cannot directly use the loop variable and can create its own variable I if it wants without any clash. The code inside the for loop can use variables in outer containing levels all the way up to the global level, as you see it does in referencing count and growth at the definition level, and sphere, which is a global variable. The higher level namespaces are effectively shared by all the enclosed levels. Again, locals at any level will hide variables of the same name in enclosing levels. This ensures that lower level code won't inadvertently mess up the contents of variables in enclosing level code. The computer science term for this is lexical scoping. MaxScript is a lexically scoped language. One final thing to explore in this example is namespace lifetime. The global namespace lives for as long as Max is running. Global variables are always accessible and usable. The rollout definition namespace lives only as long as the dialog is open. When it's opened, the variables are created. When it's closed, they're destroyed. More precisely, the memory slots used to store the variable values are created and destroyed. So, if you have the dialog up for a couple of minutes, the variables count and growth and create will live for those minutes. The other local is the loop variable I nested down in here inside the for loop namespace. This namespace is created when the for loop starts and is destroyed when the for loop ends, so its lifetime is typically very short, maybe just a few milliseconds depending upon how many spheres are being created.